Okay, hi everyone, welcome back. So this is another video, and once again I am working in Jupyter Notebook, and I'm going to use some of those data science software libraries in Python to demonstrate how to wrangle and manipulate data sets. So in this notebook, what I'll do is demonstrate how you can select different data types from a data frame using include and exclude. You'll see what that means in a second. And also, I'll demonstrate how to import variables of interest directly from a CSV file without having to import every variable or every feature in that CSV file. So we just select the variables, the columns that are of interest to us. And in addition, I'll give some examples of how to select slices of rows and columns when using the describe method when we're getting those kind of summary statistics for a particular variable or from the data frame. Okay, so I'm going to try talk a bit faster and keep this as short as possible. But as you've seen in previous videos, if you've watched any of them, I'm going to start by importing a couple of key software libraries that are going to be useful in this video. So I'm going to import pandas and import NumPy, and as ever, I'm using those nicknames. So I'm importing pandas as PD and NumPy as NP to make it easier to use those abbreviations to make it easier for me when I want to invoke methods from the different libraries. Okay, so what I'll do is first of all I'm going to import a data frame which is saved as a CSV file in a folder on my computer, and I'm gonna call it. So it's data that relates to research that I did with a number of students over a couple of years regarding a public goods game. So participants played a public goods game, and they also complete a number of different scales. And the data file is called PGG, which is obviously an abbreviation for public goods game. So it's a game theory type of scenario where participants have to they choose how much they'd like to donate to a common pool, and the return on the pool depends on what other individuals in the interaction contribute as well. Okay, so it's sort of with a lot of game theory research, it sort of looks at this trade-off between individual self-interest and kind of more pro-social, longer-term benefits, and how kind of cooperation and coordination of behaviour can emerge. So what I'm going to do is I'm just going to save this data frame as an object called PGG as an abbreviation, and then I'm going to call pandas a .read_CSV method that you've seen me use a number of times in these videos, and in the parentheses, in single quotes, as a string, I'm just going to put the name of the file, which is pgg combined data 21 and 22 .csv. So if I run that cell, it's going to import that data frame for us, and it's got quite a lot of stuff recorded in it. If I run pgg.head, if we use the .head method, you can see there are 47 columns, 5 rows, so quite a bit of different information in this particular data set. So the 5 rows is obviously the first 5 rows of the data frame, because I used the .head method, and by default it returns 5 rows. But you can see there's a lot of different columns. There's the year the data was collected, so it's collected over 2 years. There's a quantized version of the year, so 0 for 2021, 1 for 2022, I'm assuming. There's kind of an ID number for each participant, their sex quantized, so 2 is a female, 1 is a male, their age, postcode data, IMD score is kind of the kind of rank, the deprivation indices for score for their home postcode area, and various others. So what they did in this research is played 5 rounds of the public goods game. You can see people's individual contributions in each round, and then a mean contributions calculated there. and they also complete a number of scales, one of which was a scale called the consideration of future consequences scale. And although it's been pandas, so it's not displaying every single column. Pandas has condensed the data frame down here. You can't see there's a number of questions. CFC questions 2 to 11 have been kind of edited out or highlighted out of the data frame summary here. But this CFC question 1 to 12, those are the 12 questions. They've each got a quantized version, although they don't need it because they're a numerical measure. Reverse score and a CFC mean score for each participant. Okay, so lots of different interesting data in the data set. And if I run the .info method on the PGG data frame object, you can see we've got 146 participants and a variety of different data types, so mostly floats and integers, but some objects, so some string object variables in there as well, such as postcode and sex. Always useful to look at how many non-null counts we've got. So we know we've got 146 participants. A lot of the data has exactly 146 values, so we know there's no missing. But there's a couple of variables here where we've got like 134 non-null. So we know we've got like about 18 missing values for this IMD score variable here. So it's good to check those things. And I think the .info method is really useful and allows us a quick way to examine missing values and also the data types of different variables. Okay, so what I'm going to demonstrate first is how you can select different types of data. So select different data types from this data frame using select underscore d types method, and then in parentheses telling it what to include, and then we can also use the same thing but telling it what to exclude. And so if this first line here, I'm basically selecting the data frame object. I'm telling it I want it to select certain data types, and the ones I want it to include are objects. So this should, I'm using the .head method as well, so a kind of nice neat one-liner. If I run this, that should just return the variables in the data frame that are actually objects. And that's, if we can go back and check that, but that's exactly what it's done. We've got two, the rest of them are kind of numeric, but this has just selected the ones that are the ones whose data type is object, which is postcode and sex. Okay, so another thing we can do is kind of the opposite of that. Say we wanted to exclude any object string variables, and we just wanted the numeric variables. This time we're going to use pgg.select underscore d types and only ask it to include number. So notice I put number again here. Number is in single quotes, so it's been passed as a string, and what that will do is it will return all of the different variables that are numeric in value. So that will include integers and floating point numbers. So it's things that are stored as integers and things that are stored as decimals. And you can see that there. So we've got a number of that are just integers, age, but IMD score, crime rank, things like that. The CFC mean, they are saved as decimals. Okay, so as we expected, because we only have two objects in this data frame, we've now got 45 columns because it's just excluded sex, the string version and postcode from the data frame when we've used this kind of function call here. Right, so another way we can do this though is using, rather than include, we can use exclude. So I've gone PGG, which is the data frame object, select underscore d types again, but rather than include, this time I've specified exclude, and I've asked it to exclude all numeric variables. So if we run that, that should return the same data frame object as it did up here where we asked it to just include objects. So two ways to achieve the same thing essentially. Okay, so that's quite interesting. But it's a large data frame, as you can see. There's not loads and loads of participants, there's not loads and loads of rows, but there's an awful lot of variables and stuff like that. And one thing we might like to do is reduce the data frame size. So if I run this particular line of code here, pgg.info, and then I pass memory usage equals deep. If I run that, it's going to give us the info, the sort of information that we usually get when we run the .info method. But if we scroll down to the bottom, and it gives us at the bottom memory usage, and it tells us that the kind of memory usage is 69.5 kilobytes. Well, that's not huge. So, but say it was, and we wanted to reduce the size of this data frame. One way we can do that is just by importing only the columns, only the variables that we're interested in. So what I've done here is I've created a new object called columns pgg, and I've passed it a list of the variables from the pgg data frame that I'm actually interested in. So I only want these four: mean contribution, mean score, CFC mean score, sex, and IMD score. And what I can do to having kind of specified this object, which consists of just this list of variables, I can then create a new data frame object. I'm going to call it small_pgg, so it's got a different name to the pgg data frame object we created up here. But I'm going to use the pandas pd.read_csv, and I'm going to pass into that, as usual, the name of the CSV we want to import. But notice here we've got an extra argument. I've put a comma, and then I've used this use cols equals, and then I've specified the only columns to use as the ones included in the cols pgg object up here. Okay. And then what I've done underneath is a similar sort of thing to what we did above. I've specified this new data frame object, the .info method, and asked it for deep memory usage. So if I run this, what we've just done essentially is imported only the four variables that I've asked for in this list from this CSV file that's saved in a folder on the computer, and then at the same time, all in the same cell, I've just I've called the info method and asked for the deep memory usage. And you can see now the memory usage is 12.5 kilobytes. So it's reduced significantly by just kind of, rather than importing the whole data frame, just importing the columns, the variables that are of interest for whatever analysis you might be doing. So if I run that, you can see, if we call the head there, you can see we've now just got a much reduced data frame with only the variables that we might be looking to analyze in some way. So a further way to reduce memory usage is to convert objects to categories, and I kind of demonstrated this in a previous video where we changed the data type of a variable from object to category. And I said at that time that what a useful thing from this is it allows you to save memory, which can be, if you have extremely large data files, it can be quite useful. So what I'm doing here is I'm basically creating an object called dtypes for data types, and I'm passing it a dictionary. So remember, the curly braces represent dictionaries of key value pairs, and the key here I'm using is sex, and the value is category. So basically what I'm saying is the sex data type, I want it to be a category. So I mean, what I'm going to do again is import. Again, we're going a step beyond what we did just before. I'm going to import the data again, and this time I'll give it a different name still. So smaller p underscore pgd, so a completely different data frame object. We're going to use the pandas read underscore csv method. I'm passing the name of the CSV that's saved in a folder on my computer. We're going to use this use calls equals calls pgg object again, the one that I created up here, just those 4 variables. This time we're adding another argument still, and I'm saying dtype should be equal to dtype. So when we run the cell and import the data, it should convert the sex variable from an object to a category. And then I've also asked it straight away within the same cell, smaller pgg. We called the info method and we've asked for the deep memory usage there. So let me run that. What you can see here is above there, when we did this, it was saved as an object. Here it's imported it as a category. So what I did there was I read in the data frame, selecting only the columns specified in calls pgg, and then I using use calls to do that, and then I converted sex to category using dtype and specifying this dtypes object that I'd created up here. Okay, and if you notice now, if we look at memory usage, it's shown as 3.8 kilobytes. So it's reduced it down from 12.5 kilobytes to 3.8 kilobytes just by converting the sex variable from an object to a category. Okay. It's worth noting though, as I've put here, just as a comment, if the category data type will only reduce memory usage if you have a small number of categories relative to the number of rows. So as I said previously, it's kind of a numeric enumeration type of technique. So if sex here it's got 2 categories, male, female, from this data frame. So it's going to convert it to a category from a string object. It's going to save us some memory. Okay. All right. The last thing I'll demonstrate in this video is previously we've used this .describe method. So it gives us like some summary statistics. So we can ask for a summary of data using the describe method, but with a big data frame like this PGG data frame, where you've got all these different columns of variables, if I run that, what you get is your summary statistics there, your mean, your count, your mean, your standard deviation, min, max, and the quantiles and the median and things like that. And for some of them you don't necessarily want it for all these variables, and you might not necessarily want all of this summary data. For some of them it's going to be completely meaningless, such as year. Year, we don't really need to have a mean for the year and things like that. So completely pointless. But what we can do is you can ask for slices of rows and slices of columns. So we're only extracting the things that are useful to us, and we've not got to try to pick through this table of largely uninteresting data. We can just focus on the things that we want. So imagine, first of all, though, we only wanted to show certain rows from this .describe summary. So maybe we just want the 5-number summary, which includes the min, 25th, 50th, 75th, and max quantiles. So to do that, what we can do is specify the data frame object and the .describe method with parentheses. Then after the parentheses, what I'm doing is passing this .loc method in brackets and passing it a list and telling it to go, I want the rows from the min to the max. And if I run that, what we'll see now is kind of, if there was a reason we might just want that information, it's got rid of the count, the mean, the standard deviation, and that. So we could have passed other things through, and you can see we've now just got that 5-number summary. But maybe we just want certain variables as well. So we've passed a slice of row labels from min to max, but we can also pass a slice of column labels. And the way we do that, we set it up the same, pgg.describe.loc, and we're putting in the rows we want, which are from the describe function. We just want the min to the max, those rows. And now notice I've put a comma, and then we're putting the columns, and there I'm passing that as well as age colon CFC Q1. So this is basically going to give us only the columns from age to CFC question 1. So age, IMD score, crime rank, CFC Q1. If I run that, you can see it's just selected the things we maybe, for whatever reason it might be, we might be interested in. Remember, when a lot of the time when you're kind of specifying things like this, it's row, they're in row column pairs, so row, comma, column, index. With the indices here, the indexes are names in this particular case. Okay, so that's all I was going to cover in this video. Again, longer than I intended. I either speak quicker or chop these up into smaller topics. Okay, hopefully that's interesting, or hopefully it was useful. It's just kind of some more information about how to manipulate your data. And I kind of chose this data set as well because it's got all sorts of stuff included in it. It's got loads of variables. And often, as I've said a number of times, when we inherit a data frame or we do some research, we end up with quite big and messy data frames, and we've got to select the things out of them that we want or summarize them in some way. Okay,